Hi, everyone. My name is Stephen Pu, the co-founder of Taraxa, and thank you and welcome to our AMA. And today we have something very exciting to announce. If you've been following our project, you can probably see that we've announced our first incentivized testnet, Californicum, which is named after the native dandelion species in California here called Taraxacum californicum. So this stage is really, I think, a major milestone for our project, and it allows us to open up the test network to a much larger public, so that we can actually more thoroughly and strenuously test the test network for security and stability issues. Okay, so we would love for everyone to come and participate. We have several bounties in place, one for top block production, another one for bug bounties. So please come and check us out. Go to taraxa.io/run_node, and you'll be able to check out how to participate in the incentivized testnet. All right. So for today's AMA, the first thing I really want to talk about is really the network rollout, right? So I think we've been getting a lot of questions from the community around exactly what it is that we're rolling out, what does it mean, what are the different phases of the network rollout, what is the relationship of mainnet to the current network, and how does everything relate to staking, for example. So I really want to take a minute here and then get everyone updated on exactly how our network rollout works. It is a process that is very carefully testing feature by feature of the eventual mainnet network, all without risking the loss of real assets. Okay, so let's check this out really quickly. All right. So what we have here is, we have 4 different phases in the near term for the Taraxa mainnet rollout. Okay, and the first phase is, this is the phase we're in right now, right? So we are here, right? The first phase is called pre-staking. So if you followed us before, you'll probably heard this term. We've used the term pre-staking to actually talk about our staking campaign. Okay, so here what pre-staking means is that you can stake your tokens, right, on the Ethereum chain, right, and also you can run a node on our testnet network. Okay. So that's what we call the incentivized testing. Right now, between the staking and the running of a node, these two are right now disconnected. So they're not really connected. We see a lot of questions that talks about, well, how many tokens do you need to run a node? Well, right now at this moment during the pre-staking phase, you don't need to worry about tokens in order to run a node. As long as you register on our website, you'll automatically be delegated testnet tokens, and that will make you eligible to actually run a node. Right? Testnet tokens are not worth anything. The tokens that are on Ethereum right now, that's the real asset. Okay, so you can lock your tokens on Ethereum, and then you can run a node here on the test network. And the goal of this setup, right? The goal of this setup is to actually further stress test the network for security as well as stability. Okay, so the reason why we kept these two apart is, once again, we want to do this step by step, right? So first, we get a lot of community users, supporters, and investors to lock on the Ethereum network. So this actually helps us to make sure that this locking mechanism works really well, and that everyone gets used to this idea of actually staking something, right? An incentivized testnet running on the testnet this is basically trying to test the security and the stability of the network, as well as the node's operations, right? So that's the pre-staking phase. This is the phase we're in right now. Very quickly, we're going to migrate into the second phase, which is called mirror staking. Okay, why is it called mirror staking? Well, because remember how these two are disconnected before? Now we're going to mirror the tokens that have been locked on Ethereum into the test network. Okay. So the next stage is called mirror staking because we're mirroring the stake from Ethereum network into the Taraxa network. Okay. And when we mirror it over, we're taking that stake and we're going to introduce a new functionality, a set of new functionalities on the testnet, which are the core economics as related to consensus. Okay. So there's going to be delegation, there's going to be fees, there's going to be block rewards. So this connects the staking to the running of a node, right? To the node's operation. So here, remember we said in the pre-staking phase, you don't need any tokens to actually run a node. Here, in order to be eligible to run a node that actually can participate in consensus, you actually do need someone who has stake token on Ethereum to delegate to a node that you're running on the test network. Okay, so here, the staking and the delegation have become connected. But notice that because we're doing a mirroring, we're not actually moving any tokens onto the Taraxa network. The real asset here, the tokens, are actually still protected, right? So they're still safe. There's no risk that if something goes horribly wrong with the testnet, that tokens wouldn't be lost or anything like that, right? So this is still a very, very, very safe setup. And it allows us to test all the economics of the network without putting real assets at risk. Okay, so this is mirror staking. And the third phase is what we call mainnet candidate. So mainnet candidate is essentially the same as mirror staking. Okay, so this is the mainnet candidate, but it has a very, very, very important distinction here. Is that on the mainnet candidate, there can be no data loss, right? So typically speaking, when we have test networks, you'll often see this, I think, amongst a lot of projects, including our own, will say, oh, we made some changes. Now you have to wipe all the data. Everyone wipe all your data, and we're just going to start over again, right? And this happens periodically when we make, some kind of changes that might not be very easily backwards compatible, or it might just been easier to reset the network, right? For the mainnet candidate, there's no reset, okay? The network might go down, but data cannot be lost. So here we have this very strong additional guarantee here is that data cannot be lost. Okay, that's the primary difference between mainnet candidate and mirror staking, okay? And the no loss of data is critical, right? Because if you don't lose data, if you can guarantee that data is not lost, if you can guarantee that even if the network goes down, it can recover gracefully, that means your assets are protected, right? So this is really the guarantee that we're looking for, on top of course, stability, security, and the economics functionality, right? Enabled for actual proof of stake consensus. On top of these, we have no data loss and smooth recovery, even if the network does go down. So this is going to be the mainnet candidate, right? And every single step we move forward, we make sure that we add critical features and we test those critical features while minimizing the risk to assets, okay? And once the mainnet candidate has been running and we can really prove that there's no data loss, right? There's smooth recovery, all the economics work, the network is pretty secure and stable, then we're going to be able to do this token conversion. Okay, so we're going to take the Ethereum 20 tokens right now on the Ethereum ERC20s on the Ethereum network, and we're just going to disable that, right? And all that is going to migrate into the main network. So this is going to be the token conversion phase. We only do this when we're very sure that the network is secure, stable, functional economics and consensus, no data loss, smooth recovery. Then, we're able to actually convert tokens onto. This is when the real assets, right? The real assets actually make the migration onto our network, right? So that's really the 4 short-term phases. Of course, there are a lot more goals after that, things like governance, lots of technical features like rapid thinking, things like that, right? So, but these, sort of are the short-term goals that we actually have. One thing I really want to emphasize again, because we do see a lot of these questions online in the communities. Before this phase, before the token conversion phase, all tokens on the network, on the test network, they're not the real tokens, right? Because I think a lot of community members see that when you receive delegations through our community site, you actually get a lot of tokens on the testnet, and they thought, hey, this is, how can I withdraw this? How can I sell this? It's not worth anything because the testnet can be reset at any time, right? The real tokens are on the Ethereum network. Okay. The reason why you get a lot of tokens when you actually delegate is because we want to make sure each node has a lot of tokens so that later on we can run stress testing scripts, right? So things that is a concerted effort amongst the network to maybe try to break the network, right? In terms of loading, really overloading the network with transactions, with with bad traffic, trying to break it from a security or a load perspective, right? So that's why you're getting those testnet tokens. So that those tokens are not real; they're not real assets. So please be aware of that. Okay, so hopefully, you guys understand the sort of near term goals and the near term phases of our rollout. We're in pre-staking right now. There are 4 phases. The next phase is mirror staking, and we're going to be on our way towards a mainnet candidate by the end of the year. Okay. All right. So I think we posted a tweet the day before, and there are a few questions on the tweet as reply. All right, let's answer them one by one. First question, is it possible for Taraxa to be used with AI machine learning in the future? If that's the case, what are going to be the possible use cases? Okay, so that's pretty interesting because we're actually working on an application right now that actually requires machine learning and AI. So we're still developing this application, so I don't want to tell you too much about it, but essentially it's a way to actually it's sort of a social listening application. Basically, we see informal transactions, informal interactions as a large source of untapped data, right? It's very valuable, but it's largely untapped because it's not trustworthy, right? So we've seen the examples from machine-generated data to people-generated informal contracts to now, informal interactions on social media. So in order to interpret this data and make it useful, of course, we decentralize the collection and the analysis of this data. And that's usually the way to make it trustworthy. The AI component comes when we actually train specific models to identify patterns within this data, right? So one pattern that we could train to identify is, what are people talking about, for example, right? There are a lot of trends, technology trends, or trading trends, right? Actually emerge on social media well before they make themselves known on the trading exchanges or by a lot of people, right? So actually a lot of social signals tend to lead trading signals by quite a large margin, right? So it would be very interesting for people who, for example, are traders to figure out what people are talking about. There's another thing that we've been working on is, well, in addition to what people are talking about, and what are the emerging topics that someone could potentially be watching, who are the people that are instigating these new topics, right? Who are the people that are starting trends and influencing the rest of the community to actually talk about the thing that they're interested in? And these are influencers, these are KOLs, right? And this way we have like a very interesting way to identify long tail KOLs, right? Everyone knows who the guy with 1 million followers on Twitter is, right? So that everyone knows who that is. But what about the emerging KOLs, right? People with a few hundred followers, people with a few thousand, people with a few tens of thousands of followers, that are in some corner of the internet, right? Maybe they're a Reddit forum, maybe it's in, a Discord, several Discord servers, several Telegram servers, things like that, that you don't necessarily know who they are or what they're talking about. And most importantly, you have no proof of their influence, right? So, we use AI to actually mine a lot of this data or mine a lot of this insight, right, from everyday informal interactions are happening in these social media platforms. So it's actually very, very interesting. We think this is going to be a highly interesting application and a very useful tool. Still very early in development, so please stay tuned. We'll definitely update everyone once we have something to show you. Great question about AI. All right. All right. Another question. Oh, this question looks pretty technical, actually. What are the possible ways to increase the speed of node syncing process, and what will be used in California? And what will be used in Californicum testnet? Okay. So I guess I'll answer that question backwards. One thing that I did not mention across these 4 stages is actually performance optimization, right? So, like I said, these features, things like, having a secure and stable network, having the, the right proof of stake economics, having, guarantees on data loss and recovery, these, and also being able to hold real assets, right? All these actually are more important from an engineering perspective and also from an operational perspective than performance. So we actually want to make sure that we get these things first before we really start spending time worrying about performance tuning. So it's going to be after the mainnet candidate has been released. Are we going to start worrying about things like performance such as TPS or latency or confirmation latency? And we're definitely going to take a look at system resource consumption, because I think there's a lot of optimization that could be done there. And synchronization, as asking that question, is something that's definitely on the roadmap to check out. What's a way to actually speed up synchronization? Well, one way to do that, and I think it's probably a pretty common and widely accepted way, is to actually create snapshots within the blockchain, right? So maybe we do some drawing here. So right now, I think the syncing process is a pretty basic, but very safe, very conservative syncing. It just syncs everything, right? It gets everything from the other node, and so everything is okay. But what we can do is that we have we have this DAG, right? Right. So this is like a long DAG, and then we also have this PBFT chain at the bottom that finalizes that, right? So so the PBFT chain, that's already sort of a snapshot of a group of DAG blocks, right? But what we can also do is that we can also say, like, maybe let's say every 1,000 PBFT block, we have one snapshot. Like this is a snapshot, right? So what a snapshot will contain is basically a snapshot of the state, right? So this the entire network state is going to have a snapshot here. So instead of getting all the historical states and then doing all the calculations on your own, you just get a snapshot of the entire state. Maybe for every 1,000 or 10,000 blocks. We're going to figure out the number later. And then within the snapshot, one of the important things you can figure out is, well, how do I validate the current snapshot, right? Is this snapshot right? So from the first snapshot, of course, you have like a genesis snapshot. Then you can figure out, so has this snapshot been voted on by the right people, right? And so from these snapshots, you can figure out who are the eligible voters and whether or not this one has received the right types of signatures, right? And then with this, you can validate the next snapshot. Maybe you're getting another 10K, and then you get another 10K, right? So pretty soon you can reach, to your current present. Let's say we're at, I don't know, 105K or something, right? Right now, this is where we are right now. So you would just keep skipping until you get to 100K, for example. And then you do the last 5 blocks, right? 101, 102, and then all the way until you get to 105. And then once you can validate this, then you can actually move forward and start, validating other transactions on the network, and also potentially start to participate in consensus as well. The security, the security requirements for that is something that we still need to investigate, of course. But the idea is that you can actually get snapshots, right, across the network, across many different blocks and transactions, and then actually being able to verify those snapshots, and then just jump forward. So you actually end up basically synchronizing a lot less, right? 10,000, for example, if we're using 10,000 as an example, you end up using 10,000 times less, basically, right? Data, and also you save a lot of processing power, so you don't have to reprocess all of these transactions. So that's one way you can actually sync much faster, right? So I think it's actually a pretty common way a lot of proof of stake chains do this. All right, so let's see if we have any more questions here. Okay, this is an interesting question. Doesn't Taraxa prove that someone with access to a particular private key agreed on something? What if I claim I've lost my key? So that's another very interesting question. Now, this actually gets us to a larger question of, identity management, right? So, in our daily lives, right, people don't use private keys, right? Like, and also private keys are very long, very hard to remember, very easy to get lost, right? So in our daily lives, people identify themselves in cyberspace through a variety of accounts, right? So you have an email, you have a Twitter account, you have a Facebook account, you have a whatever, like Telegram account, Discord, you have lots of accounts, right? You have an account at your job, right? You have an email account at your job, you have a login access. So everyone has lots of accounts, right? These are who you are, right? These define who you are in cyberspace. So in the applications that we actually designed for informal agreements, the private key is actually associated, and they're being tied to, associated on the blockchain with these real life accounts that you actually have, right? So if you and I actually are exchanging a informal agreement through text messaging, that real life account is actually your phone number, right? You have access to that phone number. And if we're doing it through email, it's tied to email. If we're doing it through like WhatsApp, it's tied to WhatsApp. So we actually write down sort of like, hey, we know you signed with this private key, so we know that's you. But the way that you signed it, the way that this key is associated, is that it's actually associated with a specific account, right? So, yeah, I mean, I'm guessing that there are several circumstances in which this could be very, very useful, right? Let's say I lost my private key, because the private key is actually stored in a lot of our applications, either in the app itself, locally, of course, that doesn't get sent to any centralized servers, or it's actually stored in the browser, right? So part of the web application itself. Let's say you wipe the browser, your computer burned up, I don't know, you got a new phone or whatever, right? So obviously the private key is gone. The private key is gone, but your identity isn't gone, right? Like you didn't just lose all your other identity. You didn't just lose your hopefully you didn't lose your phone number from the phone company. Most likely you did not lose your email, access to your email, right? You did not lose access to your WhatsApp. You didn't lose access to any of this stuff. So the next time you use it, the system will say, oh yeah, there's no private key here. Locally, a new private key has been generated, but it's also associated with this phone number. So one identity can have many keys, right? In fact, that actually might be a way to, an interesting way to actually, provide some alternative types of security. But anyway, so you can have many different types of keys. So there's not even any password recovery, because as soon as you are interacting with the system using one of these accounts, then we automatically create the system's local system automatically create keys that are then associated with these accounts. So you don't need to worry about losing them. there's another flip side to that is what if someone tries to commit fraud, right? Like, I proved that you and I said something, and then you sign it with your, with your private key, and then I come to you later, and you're like, this never happened. I said, no, you sign it here. Like, I don't remember this. I don't have any keys, right? Well, then we go back to the same thing. We say, no, well, it's actually associated this with your email, with your phone number, or with whatever. That's definitely tied to you, right? So you can't be like, oh, that's not my phone number. No, it's pretty clear it's your phone number, right? Everyone knows it is. We can check with the phone company, we can do whatever, or it's associated with your email. So it's pretty obvious that certain accounts are owned by you, right? Now, if someone's doing business with someone else, and that guy keeps switching phone numbers or keeps switching email addresses, you don't need our system to become suspicious of that person, right? Well, why is this guy, keep switching everything, right? There's something fishy about it. So, in both cases, in terms of losing your private key or trying to cheat the system or trying to scam the other counterparty, this wouldn't really work very well because it's actually tied to the other digital identities we have in our life, and this makes everything easier, right? And makes the entire system more robust. Okay, sounds great, and I don't see any additional questions here. So, okay, thank you. Thanks, everyone. And please do come and check out the Taraxa testnet. Hold on one second. So here it is again. To figure out how to join the testnet, go to Taraxa.io. Run node, okay, and this will take you to the step-by-step guide, and it will tell you how to participate in the network and where to see all the bounties. Okay, thanks everyone, and I hope to see you on the Taraxa network.